Okay then, welcome back. Today we're gonna go ahead and create our timer.h. That will be another header, which will be used for a good number of things. So there are some fairly new technologies that we will use there. Not only new in a sense of the course, but new in sense of C++ as well, because a lot of the things here are from C++ 11, which is fairly new. And before I actually start writing the code, I would like to give a bit of an intro for this, and then we will, in the follow-up tutorial, go over the code. I strongly advise you not to skip this intro, but if you want, I can't really stop you. Anyway, this particular header, as I said, we will use for a number of things. First of all, we will need it for parallel code execution. Then we will need it for delayed code execution and for repeated code execution, calling functions within certain intervals. That is what I mean by the last one. So if we want to call a function like every 5 seconds or every 10 minutes, something like that, this will be very important for our mail timers. So we will need this header in order to set the sending of an email every 12 hours. So if you want a precise way of sending an email every 12 hours, we will need this header in order to achieve that. Now, there are two main subjects which will be dealt with here in this particular header. The first one is thread, and the thread library and the chrono library. So let's go over thread first. Multiple threads can run simultaneously within the same process. This is very important because we don't want to stop the logging of keyboard strokes while sending the email. So we want the program to be able to simultaneously record the keystrokes, send the email, take screenshots, and possibly do a good number of other things all at the same time. This is very important for us because we cannot have anything interfering with our keyboard hooks. So we want our program to be able to record keystrokes no matter what, and do a good amount of other things. That is why we need threads, so they can run simultaneously within the same process. What are threads? Well, basically a process within a process, sort of. I know a lot of people will hang me for saying this, but yeah. Anyway, the main difference between a process and a thread is that multiple threads can share the same variables and data sections, and it uses the same dynamic libs, libraries, and open file descriptors, while processes have to use separate ones or their own. They're completely detached from one another, and communication between two processes is, I would say, kind of difficult. Let's go for really difficult. While between two threads, it's rather easy. Threads also share the same memory address space, while this is not the case with processes. One of the main reasons why the communication between two threads is rather easy as well. One of the main reasons why we are using C++ 11 threads is the fact that before C++ 11, we did not have standard support for threads in C++ for Windows. For Linux, of course, this was not the case. For Linux, everything simply works, because Linux is awesome. Anyway, as we didn't have standard support for threads in C++ for Windows that were independent of the Windows platform, we had to use createThread function from the Windows API, which is not something we want here due to the fact that the management of these threads with Windows API was very difficult, to put it mildly. In general, we use thread for concurrent task execution. Keep in mind that as things are not there is not simultaneous execute. I mean, the threads themselves, even though it seems to us that the execution is simultaneous of these concurrent tasks, this is not the case in reality. Rather, instead, due to fast processor time sharing, it just appears to us that it is occurring at the same time. Because, older processors, but modern processors, let us say one of 4 gigahertz, has 4 billion machine cycles per a second. It is just that fast that you cannot tell the difference if something is happening in 1 millisecond and then something else is happening in another millisecond. You are not able to actually figure out the difference between the parallel task execution and the concurrent task execution. So even though it's executing one after another, it doesn't matter to us, because to us it seems as though it is happening at the same time. And for most intents and purposes, it is happening at the same time. I just wanted to bring a little bit of reality to you. Anyway, next, in the main function, you can just in the main function, you have this while loop, and this will be our main thread. So we will not be able to do pretty much anything else here, and we will need to create other threads if we want to do anything of significance in this particular case. So this will be the main thread, which will run on end. This is an infinite loop, and we will need other threads for other tasks. It will record keystrokes, it will send mails, take screenshots. All of these things need to be able to happen. We need to enable all of this to happen pretty much simultaneously, so to say. Also, my explanations of threads, main threads, etc., this is just something that I am using from my head and the way the code is written. So if you want to check out the official definitions, etc., please feel free to go on the net online and have a look. I just call it as I see it. So yeah, you might find that it differs to a good extent from the official definitions, etc. But what I am explaining is, in my opinion, true for the case at hand. But I strongly advise you to read up on threads online as much as you can. It will be of great use to you, I am sure. Another thing that I would like to mention in this regard is that the header will be able to block the main thread, delay it if need be as well. So if we want to pause the execution of the main thread for one reason or another, we will be able to use this timer. As you can see, a lot of the things in this keylogger that we're making now, some of the headers, some of the functions we perhaps don't use now, but this is an ongoing project which will involve a ton load of other functionalities. So it's really geared towards that. As it will expand for a good amount of time, other functionalities will be added. So we're working towards that. The idea was not to create the code now, fixed code, no more changes, etc. The idea was to create a code that will evolve over a certain period of time. Anyway, another library which we need to take into consideration here that I would like to just say a few words about is Chrono. It comes from a Greek word chrono, meaning time, and this library is used for very precise time measurements. It uses Windows API functions, which are rather precise in this regard. One of those is query performance counter, used for measuring time in milliseconds, microseconds, and even nanoseconds. Before, we used to use CTime library, which had a good amount of problems, and it was rather imprecise in a good amount of cases. But it was useful, still is, and it can still be used for a number of things, for a number of tasks as well. Anyway, that was just a short intro that I wanted to give you in this regard, and in the follow-up tutorial we will jump straight away into writing the code itself. So, by the way, I'm sorry if I've been a little bit boring without the code here, just dry talk, but I really felt the need to explain a few of these things. Even though this course is labeled advanced, I just felt like I should just say it and then jump into code.